Hello everyone, I am Snigdha Kakkar and this is my channel Accelerate AI Careers. Today I have brought you a very interesting lead code problem, lead code 1105, filling bookcase shelves. It is one of the most amazing and important questions asked in FAANG interviews as well as Salesforce and Adobe interviews in last 1 month. So it's very critical to understand how to solve this question. Now what makes this question very difficult? So the poorly worded question and lot of text is one way to say that it makes it difficult. Also, there's a confusion whenever you read this question, and your first instinct usually is to solve it using greedy approach. And that's where you make a fault and lead to a bad answer. While this question is not a greedy method approach, but and it can be solved using memoization, backtracking, or dynamic programming. So I will help you understand why it's not greedy method approach question and then how to solve it using memoization, backtracking, and dynamic programming bottoms up approach. So let's please start understanding the question first. So I explain it using the example. So you have been given a bookshelf. So we have a shelf like shown here in this example. And you have been given a parameter called shelf width, which is this. So that's your first constraint. And you have to fit in books within this shelf where your shelf width is your first constraint. And for each book, you get two dimensions, width of the book and height of the book. You have to fill them in the same order as they come in this array. You cannot do like first book and then seventh book and second book and then eighth book. No. You have to fill it in the same order as they come. You have to make decision whether you put two books in the same shelf or you distribute them. Like you put first book in the first shelf, then next two in the next shelf and whatever. That is your decision to make. But your end goal is to minimize this height being occupied of the shelf. So the constraint given to you are two folds. You have been given book dimensions and you have been given shelf. So you cannot fit more books in the shelf if the width of those books exceeds the shelf width because that's fixed. And you have to minimize the height usage of the shelf. That's your entire question. So now you would say, I can go by a greedy approach and I can try to fit in as many books as required in this first way. So say suppose in this example, I have gotten books in the same order as shown in this example. And I take the first book with width as 1 and height as 1. So I'll fit here. And I take the second book with width as 2 and height as 3. And first two books width is still less than shelf width. So I can fit them in one shelf. So I put first book here with height 1. And I put second book also in shelf 1 rather than shown here as in shelf 2. I put it in shelf 1. And I occupy the second two columns. So my max height for this shelf would be max height of these two books, which would be 3. A second book is 3 units tall. Okay. So instead of this height as shown in the example, I would have first shelf with book 1 and 2 and max height is 3 there. And then I try to put book 3 also in the same shelf, but book 3's width is 2, while remaining width would be just 1. So I cannot put it there. So I have to put it in the next shelf. And if I put it in I equal to 2 shelf, that means I've already occupied 3 units of height earlier. And I occupy 3 units of height for this. So 6 units of height. And then I get book and 4, which I can occupy with the third shelf, and book which I can occupy with the third book. And that way, my second shelf height would be max of book 3, book 4, and book 5. So my max height there would be 3. So I have occupied 6 units of height in total until book 5. If I go ahead with greedy approach. Now, no more books can be occupied in shelf 2 since maximum width have been achieved, right? If I go by greedy. And book 6 and 7 go in the next shelf. And max height there would be 2 units. So that way, my max height which I have consumed is 8 units because first shelf has book 1 and 2 as per greedy approach. Second shelf will have book 3, 4 and 5. And third shelf will have book 6 and 7. And your max height would be 8 units. Can we do better? So let's move far away from greedy approach and let's think of it. Okay. Instead of just going by stuffing the maximum width of the shelf, let's try minimizing the height of the shelf. And how do we go about it? So we go about it by using either backtracking or dynamic programming. So we basically try out all the decisions we make in a decision tree. And then we take a step back and see if that was the best decision we made. If not, then we try the other approach. And our end goal would be to optimize the height. And To do that, say suppose I start with I equal to 1 book. And if I start with I equal to 1 book, I will also start with j equal to 0 shelf. And then I'll move to j equal to 1 shelf and I equal to 2 book and so on. And every time I put in a book, I have several decisions to make. Either I put it in the same shelf, or I put it in the next shelf, or I park it, or I put it in the third shelf, like this. I will have several decisions to make there. And I can have a backtracking function where I keep on putting them and keep on tracking 2 variables. Current width remaining whenever I make a decision, and max height consumed until now. Because those 2 variables is something which I will be using, right? Max height of each shelf, right? Max height of each shelf would be the max height of the tallest book in that shelf, because that would be the space you would need for that shelf, right? So I will be tracking these 2 variables and I will try to optimize my result. My result should be minimum height. Okay. So that's how I write my backtracking function. Now, in order to explain it better, I will try coding it for you. And once I code the memoization approach, then I will optimize it to show you how we can use caching to make it better. And once I've shown caching approach, I will show you a third solution, how you can solve it using a dynamic programming bottoms-up approach. And then I will go into details of time complexity and space complexity for this question. Now, if you want, you can pause this video here and you can go through the comments in Leetcode here. And you will find very interesting comments, like people have stated that they failed to solve this question or they tried solving it using greedy approach. And you can also go to the solution provided in the Leetcode here. It's absurd. And once you go through that solution, you will doubt your Leetcode coding skills. While the coder here was not that apt, I would say. In coding that, he has put a very long code which is useless. And I find it mind-boggling. Like, you don't need that much intense coding there and that much complexities to be added to this simple problem. So let's try solving it with memoization and then move further with other solutions. And wherever you have doubts, ask them in the comments here and I'll be happy to address it. So let's code it first using memoization. So I'll write my helper function first. And that's how I solve any kind of these questions, memoization or backtracking questions. I write a nested helper function where I'll first check my first base case. My base case would be if I run out of books. So like if I've exhausted the entire books array. So how I'll check if I is equal to my length of books. If that is the case and I have exhausted, I will return 0 because then I don't need any height, right? So that is my base case. If that is not true and it's not my base case, then I will initialize my variables. So my first variable will be current width, which would be shelf width for now. And I will keep on decreasing it as I keep on putting the books in that shelf. Because when I keep, say, a book of width 1 here, then my remaining current width would be 3 in which I can put other books. So I will keep on updating this current width by decreasing the width of the book I keep in that shelf. So that's what I will do. I initialize it with my shelf. My next variable would be max height, which I will start with 0 because I have not put any book there. So my shelf height at present would be, max height would be 0. And I will also initialize my result variable, which would be float infinity for now, like the max value possible. And now I will write my nested for function to go through the books and put them in the shelves. So for j in range I, length of books, and I will first of all get width and height of each book. And how do I get that? Height of books j. So that's how I get the width and height of the book. Now to check if that book would fit in current shelf, I would check if my current width remaining, like empty space in the shelf, is less than the width of the book. If that is the case, I have to break. I cannot put it in this shelf. I have to move to the next shelf. Otherwise, if that is true and I can put this book here, I will put the book here. That means I have to reduce my current width by the width of the book. So that's what I have done. I will also update the max height, and max height needed for that shelf would be max of my current max height, which I have initialized with 0, and height of the current book. So that will be my max height, and it will keep on updating every time I put a new book in the shelf. So say suppose I put book 1 here, which was of height 1. My initial max height was 0. So my max height will get updated to 1. because I put a height 1 book there. Now say suppose I also choose to put book 2 in the same shelf, then my max height would be max of max height, which is 1, since I put book 1 there, and my current height of the book, which is 3. So then my max height will become 3. So that's how you update your max height and current width every time you stuff a new book in the shelf. Now I will also update my result, and in result you have to minimize the height, right? So that's what I would do. I would use a recurring function and I would choose minimum of my result or helper function again, and I would call that helper function on j plus 1 because I've already analyzed j here, right? So I will call helper function for j plus 1 plus whatever max height I may obtain till now, because for that shelf I have already gotten max height. So I will put that max height here and add that to helper j plus 1 for the next shelf. So I will run the same loop for the next shelf and see what the max height I get from there, and then call to the next shelf until I've exhausted the entire books array and I placed all the books in the shelves. After that, I can return result here. And that's my helper function. Now I have to call my helper function as well. So here I return helper and I will start from 0th shell. So that's my entire memoization code. I will run it. It's accepted. Let's submit. So for the time being, I haven't used any caching here. So that's why my time limit has exceeded. Now let's implement some caching also here so that you can have an optimum solution. So let's start improving this code to add caching to the solution. It's very easy, so don't be afraid. It's just 2 lines of code change, and we'll add caching and see if the code works, okay? Now for cache, I will add a cache here, and it would be a hash map or a dictionary right here. And I will replace this result variable with cache I. So basically, I will save all my result for the ith shelf in cache rather than result. And here also I will return, instead of return result, I will return cache I. And here also I will have the same cache I. And in the top here, I can also have an its condition I in cache, I will return cache I. So this way, if I have already checked for this book or this shelf, I will return it from the cache rather than going through the loop again and again. So that's the major change. Otherwise, everything remains the same. You can try running the code, accept it, let's submit. And you see our solution is doing so well here. So it was just this minor change. Instead of result variable, we used a cache, which is a hash map. And the cache variable replaces the result variable everywhere. And we put a small if condition to check if our ith variable result is already available in cache, that is, we have computed it. So we don't need to run the loop again and return cache on. So that's it. The time complexity for this question, if you are just looking naively, then you would say that time complexity is O of n square, since I'm running the length of books twice. So it would be O of n square. But let me correct you. When you are running this loop for j in range I to length of books, you're not essentially running till the length of books because you're always limited to fill a shelf by shelf width. So you cannot put all books in one shelf. You are limited by shelf width. So this loop essentially you're running till shelf width, which is W. So your time complexity here will not be O of n square. Instead, it would be O of n into width. I hope you understand that, because this loop essentially is running maximum for the shelf width, which is W. And this loop, which you are calling here n plus 0, this loop would be running for n because it exhausts in all the length of books array. So O of n into W is your time complexity. I hope you understand that. Now, what would be your space complexity? Since we are using a hash map here, I would say the space complexity would be O of n. Okay. So this is the entire solution for memoization with cache. Now you would ask me, can we solve it using dynamic programming bottom-up approach? Yes, of course. So let me show you that solution. It's not majorly very different. The time complexity and space complexity would still remain the same there, but it's just different way of coding. So let me show you that solution as well. So for bottom-up approach, instead of cache, I will have my DT array. So my DT would be initial and spell 0, because initially we would need 0 height, right? For any kind of shelf, we have not put any books. So, and what would be the length? The length I would have, say, maximum of length of books plus 1. say suppose I put one book in each shelf. So maximum of length of books plus one. Why I'm taking plus one here is I'm considering that last case, edge case, when I reach the end of the array. And after reaching the end of the array, I'm checking if I equal to length of books return 0, right? So that plus one is for that. So I'm initializing a DP array with value as 0 right now. Okay. After that, I will move this cache and helper function, everything down. So I will write for I in range, and I'll go reverse of my books array. So length of books -1. And when we go reverse, we take a step size reduction of -1 and then go till -1 because last limit is not included, right? And then I will initialize all my current width, max height, cache, this and all, and return it in cache. And so I'll copy this and then paste it here. Okay, so once I've pasted it here, my current width is shelf width. My max height is 0. Instead of my cache I would have DPI, and my DPI is initialized with float infinity. Instead of return cache I now have to update the code a bit, but let me go through it. For J in range I, width, height, books, that all the crux of the code remains the same. But instead of cache again, I would be updating DPI, where I'll be taking minimum of DPI and this DP. Instead of helper function, I will have dpj plus 1 because I don't use cache now. And instead of returning cache I would be returning dpc. So basically, instead of returning cache I here and then helper 0 here, I will remove all of this and I will return dpc outside the for. So now let's run. It's accepted. Let's submit and see our solution is still doing so well. So the time complexity and space complexity still remain the same, but in converting any question from memoization or backtracking to DP, it's just this, that instead of a cache, a hash map, you start using the DP array. And when you're going bottoms up, you keep on updating that array value. And we are updating DPI instead of cache I. And we are looping through again and again to check the minimum height possible with all of the decisions we have in the decision tree. So that's your entire code. If you have any doubts, ask them in the comments here. I'll be happy to address it. If you don't understand this question and you want me to go into depth of each step, also comment here. If you like my way of solving problems, subscribe to my channel to get notifications for your daily Leetcode challenge. I solve one problem every day. If there's any specific question you want me to solve, also mention here. Thank you.